Hello friends, today we will take one example on stress distribution in soil mass. Let us take a problem. Let's say the surface loading is having a shape of a rectangle. So it is a rectangular area and this rectangular area having a length equal to 2 meter and width equal to 1 meter. So you have a loaded area. This is D 1 meter and this is L 2 meter. This the intensity of loading Q acting over this is also known to you. Let's say it is 20 kilopascal. So this is uniformly loaded. This is the rectangular area. So on the ground, at the ground level, you have a area where the width is the intensity of loading Q, is the width, and perpendicular to the board is the length, and that's given to you. Now using Bows's theory, by approximate method of a stress distribution, you can use equivalent point load method, you can use approximate method of a stress distribution where the load is going to spread at 2 vertical to 1 horizontal. So let us do it by equivalent point load method. So method 1, is equivalent point load method, and you need to find out the value of sigma z, the vertical stress at z equal to 2 meter. So from the ground level, and we want at this point, below this point, that is the midpoint, and let's say the midpoint is A. So sigma z at A, where z equal to 2 meter. So below the ground surface, at depth equal to 2 meter, you will have to find out the value of vertical stress. So how will you do it? In equivalent point load method, convert this into, let's say I have converted into this rectangle. So how many rectangles are now? 1, 2, 3 and 4. And this is having the intensity of loading of 20 kilopascal. So this dimension becomes A by 2 or B by 2, that is maybe called A. So this becomes B by 2 and this also becomes B by 2. This becomes L by 2 and this becomes L by 2. So this dimension is going to be 1 meter and this dimension is going to be 1 divided by 2, that is 0.5 meter. So only checking you should have is the smaller dimension, that is B by 2, whatever rectangle you have, B by 2 equal to 1 divided by 2 is 0.5 meter. This smaller dimension, if I call it as A, this A should be less than equal to Z by 3. So what is the value of Z? From the ground level, we have to go down at 2 meters. So this is A is going to be 0.5 meter, is less than Z is 2 meter, so 2 by 3. Okay. So this condition should be fulfilled. Now find out the point load, equivalent point load. So there you have divided this rectangle into 4 parts, 1, 2, 3, 4. So find out for each part Q1, and because all are equal, so it is Q1 must be equal to Q2, equal to Q3, equal to Q4. Must be equal to the intensity of loading, that is Q, multiplied by the area. So area is going to be 0.5 multiplied by 1. So 0.5 meter by 1 meter. So it becomes 20 into 0.5 equal to 10 kilometer. So Q1, if I take it at the midpoint, here it is Q1, Q2, Q3 and Q4, which is known to be. So you can divide the whole area in such a fashion that the smaller dimension is less than Z by or equal to Z by 3. So we have done that. Now, if you use the Bouwsnik stress distribution, Bouwsnik stress distribution theory, then you have the equation that the value of this sigma z, that is the vertical stress at any point, is given by Kb into Q by Z square. Now here we have to find out at A. So it will have effect of Q1, Q2, Q3 and Q4, and point A is falling at the corner of this, so you should find out the radial distance. So the radial distance can be found out. This will be R1, R2, this will be R3, this will be R4. So you should be able to find out R1 equal to R2 equal to R3 equal to R4 will be under root. Now this is the x direction, this is the y direction. In the x direction, it is going to be 0.25 whole square, plus in the y direction, it is going to be 0.5, 0.5 whole square. So you can find out the radial distances, and this radial distances comes out to be 0.559 meter. Now having got this, you can now find out the value of Kb also. So Kb depends upon 3 divided by 2 pi, as you know it, into 1 divided by 1 plus r by z whole square raised to power 5 by 2. or 2.5. So you can find out the magnitude because R value you already know, R equal to R1 equal to R2, this, so you can find it out. 3 by 2 pi becomes 0.4775 multiplied by this, we can calculate it, and the value of kb that's calculated will be very easily calculated. So if I calculate the value of kb, the value of kb can be calculated as 0.4775 into 1 divided by 1 plus R is going to be 0.559 divided by Z equal to 2 meter, the value of Z. So finally the answer comes is 0.3956. So the value of kb is 0.3956. Now kb is known to us. This will be equal to kb1 equal to kb2 equal to kb3 equal to kb4, because R is equal. So we have got this value of kb. Now the vertical pressure just at the midpoint of the rectangularly loaded area at the surface at a depth of 2 meter will be given by this expression sigma z. Therefore, let us find it out, the value of sigma z. Therefore, sigma z below point A at a depth of 2 meter will be equal to kb will be common. So kb1 into q1 by z square plus kb2 into q2 by z square plus kb3 into q3 by z square plus kb4 into q4 by z square. So now because kb is already known to you, you can take it common, 0.3956, and q1 equal to q2 equal to q3 equal to q4. So it will be equal to 4 times q by z square. Now the value of q1, q2 is going to be equal to 10 kilonewton. So this capital Q1 is 10 kilonewton equal to Q2 equal to Q3. So we can write it 4 into 10 divided by z square. So z value is 2 meter, so 2 square. So this gets cancelled. So finally you get it 3.956 kilopascal. So this is the answer, sigma z. This is the answer. Now, if you want to find out by another method, you can do so by 2:1 method. So method 2 will be this one, equivalent point load method. Now let us solve the same problem by another method that is also very popular method, and it will give you the average value. So method 2 is load is going to be distributed by 2:2 vertical, 2:1 method. So this we will see how to do that. So in 2:1 method, this load is going to this from ground level, this Z equal to 2 meter. So we want to find out below the midpoint, at this point, what is the sigma Z below the point A. So this is going to be 2 vertical and this is going to be 1 horizontal, and this is B, where B is given to you as 1 meter. So this is called 2:1 method, 2 vertical, 1 horizontal method. So load is getting distributed. This is also approximate method, and this method is quite popular. Now here, if you want to find out the value of sigma Z at point A, now how will you find it out? At the midpoint, this is going to be B, so you should find out the value of Q is already given, multiplied by width B multiplied by length. So this is the total load Q, that you know it, and you can also find it out by dividing it by B plus Z into L plus Z. This is a very popular method. Now, if you take this one, there is 2 vertical, 1 horizontal. Here it is 2 vertical, 1 horizontal. So B plus this is 1, this is 1, so it becomes 2. So B plus 2, this becomes B plus 2. So we can write it B plus Z. Similarly, perpendicular to the board, that is the length, and because the load is going to spread out at 2 vertical, 1 horizontal, it becomes L plus Z. So L is already known to us, 2 meter. So this becomes 2 plus 2, and this becomes B is 1 meter, so 1 plus 2. So this becomes 3 meter, and this becomes 2 meter. So Q is already known to us, Q equal to 20 kilopascal. So we will write it 20, multiplied by B is 1 meter and L is 2 meter, divided by B plus Z, where B is 1 meter and Z equal to 2 meter, L is 2 meter and Z is also 2 meter. So finally, if you simplify it, this becomes 20 into 2, that is 40, divided by 2 plus 1, 3, into 4, that is 12. So it gives you 3.33 kilopascal. So the stress distribution here is going to be like this, uniform. So throughout, by approximate method, you will be getting like this. On a horizontal plane though, the value is going to change like this. In the previous video I have shown you, but it doesn't show you like this. It gives you only the average value. So from first method, you got the answer as 3.95. Here you got it 3.33. kilopascal. So this is how you can find out sigma z by approximate method. So both the methods are quite popular, and you can do it by both the methods. I hope the point is well taken, and today we are going to close over here. Thank you very much.